Dinosaurs, mammoths and Neanderthals are some of the celebrities in the history book of evolution. They used to thrive on our planet, but they all became extinct. And they're not the only ones. More than 99.9% of all species that have inhabited the Earth are no longer with us. Our own species has only recently made its appearance on the evolutionary stage. Our large brain made it possible for us to colonize even the most remote corners of the world, and to grow to a population of more than 7 billion individuals. Some scientists argue that it has made us all but immune from extinction. Others say we are in even greater peril than ever before.
We're entering a period when the level of risk is much greater than ever before. There is a significant probability that we will fail permanently and end the human history in this century. We are doing things and are going to do things in this century that have never been done before. We are going to develop extremely powerful technologies that will enable us to manipulate and reconstruct the nature of life and get control of matter on the atomic and molecular level.
No one knows if humanity is at the beginning of its journey or approaching the end. It didn't take long for popular culture to develop a special genre around this subject. Now, even scientists are taking an interest in the disasters which could bring about the end for our species.
For most of human history, there really wasn't that much we could do about existential risks. But now we've reached a point where, through our science, we are able to understand some of the things that could threaten our existence.
Are we mainly threatened by natural phenomena? Or will we bring about the end all by ourselves? And what are the odds that an extinction-level event will occur this century? We'll be seeking answers to those questions. Our closest star, the Sun, is a prerequisite for life on Earth. Without it, there would be no plants, animals, or humans. But the powerful physical processes which occur inside stars can also extinguish life. When a star dies in a violent fashion, we may be unlucky enough to be directly in its path.
Believe it or not, we are literally looking down the gun barrel of the most titanic explosive event in the entire universe.
On March 19th, 2008, instruments recorded a very distant stellar phenomenon that is unparalleled in the history of astronomy. The final phase during the life of a giant star. A supernova powerful enough to produce a so-called gamma-ray burst.
So here is a massive star. It collapses to form a black hole, and along the axis of rotation, energetic charged particles can go flying out at nearly the speed of light. They burst through the surface of the star, produce two oppositely directed jets, a gamma-ray burst.
If a gamma-ray burst were to occur in our neighborhood, the consequences for us would be catastrophic.
If that beam were to hit the Earth, first of all, it would wipe out our ozone layer, so that harmful radiation would go right to the surface of the Earth, and life itself would be endangered.
One of at least 5 extinction-level events occurred on our planet 450 million years ago. More than 50% of all animal life on Earth was wiped out. According to one theory, a gamma-ray burst may have contributed to the disaster with its harmful cosmic radiation. If a gamma-ray burst devastated the Earth 450 million years ago, it may happen again. And scientists have discovered a star that is approaching the very end of its life, and that may produce an enormous gamma-ray burst at any time. This is WR104. Compared to the star that produced a gamma-ray burst in 2008, it is practically next door to us. And astronomers now know that its rotational axis is aligned within a few degrees of Earth. If WR104 were to send a gamma-ray burst towards us, it would have dire consequences for our planets.
By the time the radiation hits here, it's going to be very much attenuated. But it'll be sufficient to cause disruptions in the upper atmosphere, enough to wipe out the ozone layer at the minimum.
We would be subjected to dangerous levels of ultraviolet radiation, and the buildup of nitrogen compounds would result in acid rain.
Crops would wither, the food chain would gradually collapse, life in the oceans would be extinguished, and so with the food chain of the Earth paralyzed, it means all life on the Earth will begin to crumble.
But a gamma-ray burst isn't the only threat we would be facing from a collapsing star. What is left after the explosion, a black hole, could cause even bigger problems.
A black hole is the most monstrous, the most fantastic object in the entire universe, because everything that tries to come out goes right back into the black hole.
Scientists have long known about the large black holes that form the central hubs in spiral galaxies. Our own solar system orbits a black hole in a stable orbit at a safe distance of 27,000 light-years. But the black hole that was discovered 10 years ago came as a shock to the scientific community.
In 2001, we were looking at the night sky, and something was passing in front of the stars. Starlight was distorted. Something was moving in front of the stars that was invisible. We tracked it, and we find, oh my God, it's a wandering black hole. Black holes are not stationary. They actually can wander throughout the galaxy. And we began to realize there's a new threat: wandering black holes that are totally unpredictable.
Scientists now believe that there are thousands of wandering black holes in our galaxy. These leftover remnants of supernovas have been hurled out in every direction throughout the Milky Way.
They can collide with other black holes to be flung out in different directions. So that's what we think happened here. It was probably a collision of some sort that then drove this black hole into an orbit around the Milky Way galaxy.
If a black hole were to pass through our solar system, we would be in immediate danger.
If a black hole starts to get close to our solar system, we would know that the outer planets, their orbits are distorted. They begin to wobble.
Once the black hole passes by Saturn, it would start to affect the Earth's orbit. It would push the Earth towards the Sun, or push us out into space. And it might devour us completely. But for that to occur, the cosmic vacuum cleaner would have to come within a measly few hundred kilometers of Earth. The odds of being hit by a gamma-ray burst this century are minimal, about 1 in 10 million. The odds of a close encounter with a black hole are even slimmer.
This is one of the risks from nature. We know something about them, which is that they are very rare. It would be extremely unlikely if one of these blasts hit us within the next 100 years.
That's why the threats from collapsing stars end up in the 10th and final spot on our list of annihilation scenarios. The next threat on our list is a lot more likely to occur. No one noticed as it came hurling towards us a few years ago, and no instruments caught it as it passed us by, at a distance less than a third of the way to the moon. It wasn't until 3 days after the close miss that the large asteroid 2002 MN was discovered. If its orbit had been just slightly different, it would have hit Earth with enough force to wipe out a city like, for example, Stockholm. There would have been no warning, and the results would have been devastating.
End. Fini. Everybody in Stockholm is dead.
We live in the middle of a shooting gallery. There are things whizzing by all the time that we are totally oblivious about. At night, if you could somehow illuminate all the objects that are drifting by the Earth, you'd be shocked.
From a humble cubicle in an ordinary office landscape, millions of cosmic projectiles are being watched.
Here's my office here. This is a diagram of where some of the potentially hazardous asteroids are right now. If we plot the orbits of these asteroids, now you can see that we have a lot to worry about.
Paul Jodas's morning routine would make anyone wish they'd stayed in bed. Automated software allows for information regarding newly discovered asteroids which may impact Earth to be sent directly to his inbox.
So we have, for example, a new object that was discovered which has a possibility of an Earth impact in the year 2071 with a probability of about 3 in a million. This is a new discovery overnight. So every day we have something new.
But an object the size of a high-rise building, like 2002 MN, would impact Earth without warning is unfortunately not an unlikely scenario. Half of the asteroids approaching us have the sun on their backs and are therefore impossible to detect in advance. And there are plenty of objects left to discover out there.
Of the ones which cross the Earth's orbit and pose a potential threat to Earth, there are about 1 million of them. And of those, today we only know about 1% or less, in fact a fraction of 1%.
The most serious known asteroid threat right now comes from Apophis. It's a mid-size asteroid with a diameter of 270 meters. It weighs 20 million tons and could eradicate not only Stockholm, but all of northern Europe, as it would release enough energy to match 65,000 Hiroshima bombs. Make a note in your calendar for Friday, April the 13th, 2029. That's when Apophis will pass by Earth at an altitude of only 29,000 kilometers, lower than some man-made satellites. There are several possible ways of deflecting an incoming asteroid. Given plenty of warning, the best course of action would be to use a so-called asteroid tugboat.
You hover in front of it like a helicopter, okay, and you're pulling it toward you using gravity. You never touch it. If you want to slow it down, you hover behind it. And you stay the same, you stay close to it, but behind it, and you're slowing it down. And you either speed it up or slow it down to deflect it whichever direction you want it to go.
Rusty Schweikert used to be an astronaut in NASA's Apollo program. He now spends his time trying to bring about a global strategy to deal with the threat from above.
You may think in Sweden that the European Space Agency or NASA in the United States has a responsibility to protect the Earth from asteroid impacts. You're wrong. We have not made the necessary testing, and we haven't even done the analytic job that we should, because nobody has responsibility.
But an asteroid the size of Apophis would not endanger humanity as a whole.
They're going to wipe out a city or a region or a state or something of that kind. But when they get up to 2 kilometers or so in diameter, now you're talking about a global disaster.
Astronomers have discovered more than 800 asteroids close to Earth, which are more than a kilometer in size.
Once you reach 3 kilometers in diameter, it really becomes a very serious global event where there is a possibility that humanity could succumb. If you go up to 10 kilometers, then it might be more likely than not that humanity would die.
The asteroid that wiped out 75% of all life on Earth 65 million years ago, including the dinosaurs, was about 10 kilometers in size. The explosion set the stage for small mammals, from which we humans would later evolve. But we can't know if we would be among the minority of species which would survive the next huge impact.
You would have, obviously, an immense shock during the actual impact, but with a large asteroid strike, it could inject a lot of soot and aerosols into the atmosphere, which would block out the sunlight, and you could get a long period of darkness and below freezing temperatures around the globe. And it's probably through these climatic effects in the aftermath that the last human survivors would perish.
Well, there's a good one today, JU-39. Okay, check it out.
In all probability, none of the larger asteroids will be on a collision course with Earth in the immediate future. The real threat to humanity comes from another direction.
The real danger is not asteroids so much, because we track them. They go around the sun in very periodic orbits. The danger is comets.
The bad news is that they travel at twice the speed, and that they can be enormous.
They could be as big as Pluto. We now realize that Pluto itself is not really a planet. It's a comet, an overgrown comet. And beyond Pluto, we think there are other objects just as big as Pluto.
But the really bad news is that most comets, even the large ones, are completely impossible to spot.
In a worst-case scenario, a comet makes a first pass around the sun, so there's no tail. We don't see it at all. It is totally invisible. As it goes around the sun, we see this gigantic tail coming out with a comet at the front, and we have 2 weeks warning, and all we can do is cross our fingers and hope that it misses us.
An asteroid with a diameter of 3 kilometers could potentially wipe out humanity. But the odds of one of these heading right for us this century are slim. And so the threat from space projectiles ends up as number 9 on our doomsday list. The next threat on our list is twice as likely to occur. When the Earth's interior awakes, it's best to stay clear.
Volcanic eruptions are the most extreme kind of event that could happen on the Earth today.
The most dangerous volcanoes are so huge that people don't even realize they're standing on one.
Many of the visitors don't realize they're vacationing in one of the world's largest active volcanoes.
When the Earth's largest volcanoes awake, every single life form on the planet is at risk.
Supervolcano eruption might be the one type of catastrophe that in our past has come closest to causing human extinction.
Times were hard for the people who inhabited the Earth 75,000 years ago. One of the Earth's recurring cold periods had begun. The temperature was dropping, and things were about to take a turn for the worse. On the other side of the world, on the island of Sumatra, an enormous volcanic eruption occurred. The volcano, called Toba, pumped out several thousand cubic kilometers of magma and sulfurous gas into the atmosphere. Our ancestors in East Africa would have seen the sky growing darker.
You would have seen the sun much, much dimmer. The sky would be almost overcast. Global temperatures dropped. It would have been freezing temperatures at the equator.
Scientists believe that the volcanic winter caused by Toba's eruption lasted more than 5 years, and that it almost led to a total disaster for humanity.
We know that from modern genetic studies of human beings that we went through a population narrowing about 75,000 years ago, about the time when the Toba eruption happened. We reduced the numbers to maybe a few thousand individuals.
It's been described as humanity's most critical hour.
Really, the human species then was teetering on the brink of extinction. So according to the Toba catastrophe theory, this immense supervolcano was responsible for virtually, almost causing the extinction of the human species.
And eruptions of this magnitude are not just things of the past.
For volcanoes, especially supervolcanoes, it's not a question of if there's going to be another eruption, it's just a question of when the eruption will be.
The main candidate for the next super eruption is actually also one of the world's most visited tourist spots. Three million tourists visit Yellowstone each year to enjoy the scenery and the wildlife. But many people don't know that they're standing on the lid of one of the world's largest active volcanoes.
Most people, when they think of volcanoes, they think of something blowing up and then it ejects material to the sides and it tends to form a steep, sided, conical hill. A caldera is where so much material is ejected, 1,000 cubic kilometers, such that the ground subsides into a large depression.
Yellowstone's caldera is enormous, 40 kilometers wide and 80 kilometers long. And 2 kilometers down is a gigantic magma chamber, pushing up from below like an enormous pressure cooker that will explode at some point in the future.
Will there be future eruptions in Yellowstone? Definitely. There is no doubt about that. Now, do we have earthquake swarms? Absolutely. Do we have ground deformation? Absolutely. Why is that not indicating a potential eruption? Because they're all in different areas. So they're not caused by this movement of molten rock in one area.
Yellowstone is a supervolcano which, historically, has awoken with eerie regularity.
It has a cycle of super eruptions which is fairly regular, about once every 600,000 years. The last one was a little more than 600,000 years ago. So you might say, in a sense, according to the past behavior of the volcano, that we're overdue for a volcanic eruption.
When it's time for Yellowstone to erupt, cracks in the ground will open up and lava will be spewed out. First in one spot, then in several. Eventually, a ring of cracks will cause the lid to collapse and the magma chamber will explode upwards. An enormous cloud of grey gas will be formed as the volcano erupts. This is called a pyroclastic flow, and it consists of superheated steam. It spreads in all directions, travelling at several hundred kilometers per hour. Nothing in its path can survive. This is Bozeman, the fastest growing city in Montana, and a natural starting point for a visit to Yellowstone. It's 100 kilometers away, but it will be eradicated by the pyroclastic flow. Smaller particles in the DOOMSDAY cloud will reach an altitude of 25,000 meters and spread across the entire atmosphere.
The main effect of super eruptions on society would be the climatic effects. In the worst case scenario, you would have maybe up to 5 or 6 years in which the growing season would be cut short or probably maybe even eliminated completely. For now, we don't have any of the kind of stockpiles of food that we would need to get through a volcanic situation.
An incoming asteroid might be deflected, and diplomacy can avert a full-scale nuclear war. But there's no stopping a supervolcano. The odds of a supervolcano erupting in our lifetime are slim, maybe just 0.1 or 0.2%. And hopefully, enough of us will survive to restart civilization. But historically, supervolcanic eruptions have occurred more than twice as often as large asteroid or comet impacts. And so the threat from volcanoes ranks higher than that from space projectiles, at number 8 on our list. The next item on our list is in the category of unknown threats. It was recorded just before midnight, one night in August 1977. A signal that caused the instruments at Ohio State University's radio telescope to spike. The signal came from a spot in the sky just east of the star constellation known as Sagittarius, 220 light-years away. The signal was so clear that the operator made what has become a famous notation on the computer printout.
What made the wow signal interesting is that the signal shape, the way the signal went up and down with time, perfectly mimicked the kind of shape you would expect from a signal coming from one spot on the sky, moving with the stars.
During the search for extraterrestrial intelligent life, the wow signal is the only signal that cannot be explained as a natural cosmic phenomenon, or the result of human activity.
In the case of the wow signal, of course, we don't know what it was. It was never seen again.
Could they be out there? Advanced creatures that have been portrayed in books and movies? At times they've come in peace, but for the most part, their plans have been much more sinister.
All right, here we go. This is our first exposure of the night. Go, we're shooting.
No one knows if there is life on other planets. But given the rapid advances being made in astronomy, it's most likely to be only a matter of time before we know the answer.
10th magnitude. Well, we are living in a very special time. And now, finally, for the first time in human history, we have a chance to find the first Earth-like planets orbiting other stars and find some of those Earth-like planets that are habitable, suitable for life as we know it.
Since the first discovery was made in 1995, planet hunters on both sides of the Atlantic have come up with an inventory of about 500 so-called exoplanets, planets which orbit around other stars.
So you saw that from the first detection 15 years ago, when we were basically detecting only if there is a planet and what about is a planet. Now we move very far along the way that we start to tell you what is the temperature on the planet, what is the size on the planet, what is the gravity, is it rocky, is it gas, could you land on this planet, basically? So we're really moving. It's like a science fiction book, but it's not science fiction, it's reality.
This is the first star that was found to have planets which could sustain life. Gliese is a solar system just 20 light-years away, and like our solar system, it contains several planets. Both the planet called 581G and possibly its outer neighbour 581D may be able to sustain life. Since Earth-like planets have been found in such close proximity to us, after such a short search, scientists believe that the number of Earth-like planets in space could be enormous.
So there are so many stars in the galaxy. There are 100 billion stars. So I must expect to have millions of planets with life.
But whether or not the galaxy is abundant with intelligent life is a completely different question.
You see this very obvious line here. That's a signal, and that's the kind of thing we're looking for. Because
at SETI, the search for extraterrestrial intelligence, people believe that it's only a matter of time before we establish contact.
Keep in mind that there are just an awful lot of worlds out there. Maybe 1% of them are interesting, or 1 in 100% of them are interesting. When you have 1,000,000 of them, it really doesn't matter.
People have been listening for extraterrestrial signals for almost 50 years now, but so far nothing more promising than the WOW signal has been picked up.
But that'll change. I think that'll change. This array will allow us to search enormously faster. And so with this thing going, you know, in the next 24 years, you could check out 1,000,000 star systems. That's the antenna that I think could find ET in the next 24 years.
But then, could aliens pose a threat? No one has a problem with just listening for signals, like at SETI, but what this man does has caused some raised eyebrows. Alexander Zaitsev is a Russian radio astronomer. No one has done more to send messages into space than him. His latest message was transmitted in 2008 to the Gliese solar system.
То мы как бы в деле наведения моста между нами и предполагаемой цивилизацией мы прошли свою часть пути. We make our part of job. И теперь только от них зависит, от них, будут ли обнаружены наши сигналы, смогут ли они их расшифровать.
If there are beings in the Gliese system that are able to receive his message when it arrives in the spring of 2028, they would find out quite a lot about us. The message includes a list of Earth's natural resources, such as minerals and metals. A map shows how the continents are aligned, and included is also a guide to the genetic makeup of humans.
There are conferences that have been organized about this. The reason that we consider them is because it's a highly emotional subject. And it's an emotional subject because there are some people who think it's dangerous and they don't think that anybody should do it. And some people will object and say, yeah, sure, there's all this, you know, our television and so forth has been going into space, but that's a pretty weak signal. What we should try to avoid is any deliberate broadcast that would make a very much stronger signal going in the direction of some particular star system.
Alexander Zaitsev shrugs off the criticism.
Нет ничего, вот как мне кажется, что нет ничего такого, что мы могли бы сообщить, что представляет опасность. И когда формируется цифровая часть радиопослания, то излагаются некие общие сведения, которые нам известны о Вселенной и о нас.
Ours might be the only civilization in our part of the universe. If so, we could scratch aliens off the list of threats. But if intelligent beings are a common occurrence, it could very well be that violence and aggressive behavior is a characteristic of aliens, just as it is with us. Then we could be in trouble.
If you look at the history of humanity, every time a more technically advanced society met a less technically advanced society, it didn't work out so well for the less technically advanced.
If aliens wanted to get rid of us, they would most likely be able to accomplish just that.
Well, the chances that they're only 50 or 100 years or 500 years more advanced than us, just statistically, that's not very likely. It's much more likely that they're thousands or millions of years more advanced than we are.
Looking down on Earth at night would make it clear where to launch an attack, if an aggressor should wish to maximize the effects. Since we most likely wouldn't survive an encounter with aggressive aliens, this threat ranks as number 7 on our doomsday list. next threat on our list is anything but unknown to us. In many ways, these are the most successful entities on Earth: bacteria, parasites, and viruses. Every single animal or plant has its own virus strains. The host animal can often coexist peacefully with its inner companions, but not always.
Among the global catastrophic risks, natural pandemics is up at or very near the top.
They have killed us in large numbers throughout history, and they will do so again.
Now, with global travel, a pandemic could spread very quickly to all parts of the globe. So our past track record of surviving these events cannot give us a 100% guarantee that these will not occur and be universally deadly in the future.
The people of San Francisco celebrate. You've seen the signs they carry.
The year is 1918. People all over the world celebrate the end of World War I, like here on Market Street in San Francisco. A 4-year-long war is finally over. But as the war is ending, the real enemy appears. A lot more deadly than artillery shells or poison gas. Looking closely at the celebration, you notice that people are wearing face masks. An influenza pandemic called the Spanish flu is spreading like wildfire. Almost half of the world's population is infected, and around 80 million people die.
You will find any cemetery in Britain, you will find 1918 deaths. The final toll with the flu pandemic globally was much more than the toll from the First World War. Much, much more.
Why the 1918 flu pandemic came to be so devastating is still not fully understood.
Heavens, it's the biggest, in a sense, the biggest unsolved mystery of the 20th century. How could 18 million people suddenly vanish?
John Oxford believes that the almost century-old virus can teach us something about how to deal with future pandemics.
So this young person, actually he died in Prague, he died in 1918 of the influenza, the Spanish influenza. That's a piece of his lung. If we can identify a gene here, or 2 genes or 3 genes, which definitely correlate with the virulence potential of the 1918 virus, I think we can apply that information directly to the current situation.
Today, almost a century later, there are virus strains like bird flu and swine flu. On the surface, they may seem a lot less harmful, but Oxford urges caution.
What I'm saying is, bird flu hasn't killed many people yet, but it's still evolving and could perfect itself and gain the ability to jump out of Southeast Asia and begin to spread. The fact of the matter was, in that great camp at Etaples, that's the number of deaths they had there. They had about 200 deaths. But within 2 years, that virus had taken off. It's like an aeroplane. It had gone up to speed, taken off, and killed 80 million. That is the threat.
Viruses enter our cells and start replicating using the cell's own resources. The worst ones are RNA viruses. They lack a control function, and this leads to a high rate of mutation. Most mutations are not viable, but some will survive and spread.
It's like Darwin. That's the situation. You know, the survival of the fittest. And this virus makes sure, by throwing off all these mutants, that there will be one mutant that is the big boy on the block. It is the most fit virus, and it's that one which will take off.
Things get worse when an RNA virus from another host animal infects us. Different virus strains can combine, and the result will be virus strains that the body's immune system is completely unfamiliar with. The HIV virus made its way to humans from monkeys a century ago. SARS and Ebola originated in bats. A virus that makes the leap from animals to humans is called a zoonosis, and virus hunters like Nathan Wolfe keep discovering new ones.
Sometimes pets, wild animal pets, are kept in villages, which means maybe bites, children get bites, people get bites. When you hunt and butcher animals, you actually are going to have a tremendous amount of potential for contact with the full range of blood and body fluids that potentially could harbor these infectious diseases.
Scientists at the Royal Institute of Technology in Stockholm have access to powerful virus-spreading simulation software, and they've used this to establish how society would be able to deal with a pandemic on the order of the 1918 flu pandemic. And it's not a pretty picture.
Det här scenariot då är ju en person smittad i Sydostasien som anländer till Arlanda. Då har vi, när planet landar, 5 personer, inklusive den här första då, som är smittade. Och sen sprids smittan naturligtvis vidare över hela landet ganska så raskt.
The virus spreads in homes and workplaces, but mostly where people gather in large crowds. To develop and distribute a vaccine in time is impossible.
Det börjar hända riktigt stora saker efter ungefär 2 månader. Så i vecka 8 har vi knappt 100 000 och i vecka 9 300 000. Och sen stiger det väldigt snabbt tills i princip hela populationen är berörd av det här. Antingen smittad eller avlidna.
The simulation provides a scary picture. Almost 7 million Swedes are infected and 500,000 people die. On a global scale, 70% of the world's population would become infected, and 1 billion people would die. But could we get virus strains which have the potential to cause even more death and devastation, or even threaten our very existence?
What's to say that next time you wouldn't get something, say, with the virulence and lethality of Ebola, yet with the transmissibility of the common flu, and maybe with the incubation time of HIV/AIDS. If you did get something like that, clearly the results would be very nasty indeed.
A diabolical virus could spread around the world like a Trojan horse, without us even noticing it, only to wipe us out at a later date. It's an unlikely scenario, but it cannot be ruled out.
You should never underestimate a virus, any virus. Never, ever, ever.
There seems to be no in principle reason why nature could not do this. It might require some improbable combination of evolutionary events, but as an existential risk, I think it's probably as large, or perhaps larger than any of the ones we've considered so far.
The threat from microorganisms ranks as number 6 on our list. We went from tree-living monkeys to human in about 6 million years. Our path to this point has been lined by disasters and death. Dangerous predators, recurring droughts and ice ages reduced our numbers. But a small remnant always managed to survive and has brought us to where we are now.
Considering that we have survived all the risks from nature for 100,000 years, it doesn't seem very likely that one of those would do us in within the next 100 years. And therefore, I believe that if we go extinct within the next 100 years, it is much more likely to be as a result of anthropogenic risks, risks of our own doing.
There are plenty of existential threats facing humanity. Some are not at all unlikely, but they may just reduce our numbers. Other threatening scenarios are less likely to occur, but may have the potential to wipe out humanity in its entirety. On our top 10 list of disasters which may wipe out humanity this century, threats from nature occupy spots 10 through 6.
We have survived asteroid impacts, climate fluctuations, etc., etc. It doesn't seem very likely that one of those would do us in within the next 100 years. And therefore, I believe that if we go extinct within the next 100 years, it is much more likely to be as a result of anthropogenic risks, risks of our own doing.
From a distance, the city of Pripyat looks like any other concrete city built in the Ukraine during the 1970s. But as you get up close, it's clear that something is amiss here. Not that long ago, tens of thousands of people lived here, but it was turned into a ghost city by a catastrophe caused by man.
So now we're pretty close to reactor unit number 4. We'll make stop on
The technicians at the nuclear power plant in Chernobyl did not wish to cause a disaster. They were simply experimenting to find out what would happen if they ran the power plant's turbines without an external power supply. The meltdown at Chernobyl on April 26, 1986, released high levels of radiation, rendering the area uninhabitable for centuries to come. The question is, could we cause even greater devastation? A disaster so serious that it would completely wipe us out. Three weeks before the atomic bomb was dropped on Hiroshima, the first nuclear weapons test ever was conducted in the desert in New Mexico. The so-called Trinity test on July the 16th, 1945, had caused a certain level of anxiety beforehand. As early as 1942, physicist Edward Teller argued that an atomic bomb could, in theory, start a chain reaction which would ignite the entire world's atmosphere.
It's a little nuclear reaction happening in the bomb, but maybe all the atoms in the atmosphere could also sort of be dragged into this chain reaction. And the concern was taken seriously enough that there was actually a report commissioned, and some physicists were set at the task of calculating whether this would happen.
Scientists now know what it would take for Teller's doomsday scenario to become a reality. But at the time of the Trinity test, the physical effects had not been fully explored. In spite of this, the test was carried out.
We now know it was physically impossible for it to happen. But it's still interesting to reflect just how confident would you have to be in your calculation in order for you to be willing to risk humanity's future on its correctness.
Today, scientists are conducting other kinds of physics experiments. At CERN, outside Geneva, they have constructed an enormous particle accelerator in order to conduct experiments involving unprecedented energy levels.
So this is the room from which we run and record good data coming from the collision of the two LHC beams.
In a 27-kilometer-long tunnel, large magnets are used to accelerate protons to nearly the speed of light. As they collide, new particles are formed, and scientists hope that they'll help us to understand the makeup of the universe. This footage is from March the 30th, 2010. People are excited about the particle accelerator just having set an unprecedented record.
For the first time, two beams were accelerated up to 3.5 TeV per beam, and we immediately saw in our detectors the results of these unprecedented collisions producing sprays of particles in the experiment. And clearly we had the awareness that the new era in particle physics has started with exploration of a new territory.
But there are those who believe that the experiments in Geneva will bring about the end of the world.
The scientific progress that the Large Hadron Collider represents is enormous benefit, not only to particle physics, but to all kinds of theoretical physics. But we also want to make sure that the risks are assessed and known before we go forward with this. The cost of an undesired outcome is incredibly large. In this case, it would be the loss of the entire planet. And therefore, a number of people felt it was their civic duty, their duty to the Earth, to humanity, to put a halt to things until this evaluation could be done properly.
And Wagner has got support from this German professor.
A physicist should always bend over backwards to try to find the weakest points in his own ideas. So I'm just one of those people who say, play it carefully.
Otto Rössler maintains that the scientists at CERN took a risk on that day in March 2010.
The energy of these collisions was raised by a factor of 4 against my warnings this year. And when these numbers become as high as planned, I once calculated a risk of about 8% that the Earth might be, how should I say, shrunk to 2 centimeters in a few years' time.
Several different scenarios have been proposed for how high-energy physics experiments, such as those taking place in the Large Hadron Collider, could potentially pose an existential risk to humanity.
The probability of having a resident black hole inside Earth. And this probability
Otto Rössler is a professor of mathematics.
This is the energy.
And according to his calculations, the colliding particles could cause small black holes to form.
In this field of black hole theory, still new discoveries can be made. And I believe that my group made a discovery in that area. And black holes might be formed, very tiny ones, at high enough energies of collision.
So far, the accelerator is only run at energy levels which Rössler sees as acceptable. But this is about to change.
We are making huge steps to go up in the intensity of the two beams, and actually these days we are making yet another step of factor of 2 or 3 more intensity in the collisions.
And this is what concerns me, because my results say that in this area there is a certain finite probability of disaster.
Black holes are regions in space where gravity is so strong that not even light can escape. It is believed that there are large black holes in the center of galaxies, and that stars collapse into medium-sized black holes when they eventually run out of fuel. But in theory, a black hole could be infinitely small, and in that case one could be created in Geneva. According to Fabiola Ginotti, that's exactly what they're hoping to accomplish there.
Let me tell right away that production of mini black holes will be a very important, a very nice discovery. So we are keen actually to produce black holes. These are particles that can be produced if there exist additional dimensions and microscopic additional dimensions. Then production of mini black holes could be possible, but these mini black holes evaporate instantly, and so they will be completely harmless.
But Rössler argues that man-made black holes would have properties not found in black holes in space.
My results show that these little black holes will not disappear, and if they happen to be slow enough to stay inside Earth, they will eventually eat the Earth from the inside out. And the question then is only how long this will take.
In Rössler's doomsday scenario, the man-made black hole would drop right through the particle accelerator's containment field, Gravity would pull the hole towards the centre of the Earth, where it would grow larger by absorbing the atoms surrounding it. First slowly, and then at an ever-increasing rate.
It would just have the features of a quasar, meaning it would have two jets coming out in two directions, which eventually would come out of the Earth in both directions, and then people would know that there is this active machine inside, which is going to eat it inside out in more or less short time.
The people at CERN acknowledge that man-made black holes may behave in ways which are difficult to predict, but they don't believe that we are at risk.
You're right, we don't know what the outcome will be, but the fact that this experiment, which we do at the LHC, nature has been doing that for 4.5 billion years, means that whatever is produced, which we do not know, is not dangerous for us.
The risk that the scientists in Geneva might conduct a doomsday experiment is most likely non-existent. So far, no other prominent physicist shares Rössler's concerns regarding man-made miniature black holes. But no one knows what future scientists might construct in an effort to tame the force of nature. On our top 10 list of existential threats, dangerous physics experiments occupy the number 5 spot. Physics experiments may come under the category of theoretical threats, but our next scenario is very tangible indeed. It's summertime in Antarctica in January 1909. Polar explorer Ernest Shackleton has just abandoned his efforts to reach the South Pole. On his way back to the base camp, he discovers something that will radically alter our perception of this icy continent. A piece of fossilized wood. And he also finds a piece of sandstone bearing the clear imprint of a plant. There can only be one possible explanation for the presence of these items. This now sterile environment was once the site of a tropical forest. The climate of the Earth varies over time, a fact not well understood in Shackleton's time, but something we now know to be a fact. At times, the Earth's surface has become entirely frozen, and there have been warm periods, for example, the one known as the Paleocene-Eocene thermal maximum. Biological diversity was reduced in the heat around the equator, and life made its way towards the polar regions.
There was no ice in the world, no ice sheets. Antarctica and Greenland were not covered by ice, and we know that in the Arctic and the Antarctic, there were actually crocodiles living and palm trees.
We are now heading towards a new warm period, and this time we're the ones causing it.
What we're doing is gambling with a planetary life support system. And we're talking about an experiment on the real Earth with us and all the other living things along for the ride. What we don't know is, do we have a decade before it's too late, or do we have a century?
The signs of global warming are clear, and virtually all climate scientists now agree that we are facing serious changes to our climate.
I wouldn't rule out right now that the melting that you can already see on Greenland has already created an irreversible situation that we won't even know is an irreversible situation for 25 to 50 more years. And then once it starts, you can't stop it. And that's what we call a tipping point.
Scientists know that we may experience a sharp rise in temperature based on their studies of prehistoric times. Around the time when Shackleton's finds were deposited, 55 million years ago, something happened which led to a sharp rise in global temperatures.
There was a warming which took place relatively rapidly, as rapidly perhaps as the warming that we're causing now by putting more CO2 into the atmosphere.
We associate the greenhouse effect with the tiny molecule called carbon dioxide, but there are even more powerful greenhouse gases. Methane is 20 times more powerful as a greenhouse gas, and it's believed that a sudden rise in the level of methane in the atmosphere set the stage for the warming 55 million years ago. Climate scientists fear that we'll reach a tipping point where the dormant methane is brought back to life. The greatest deposits of methane on Earth are found here, in the Siberian tundra and on the bottom of the East Siberian Sea. And no place on Earth is experiencing a sharper rise in temperature right now. It's not a good combination. Örjan Gustafsson at Stockholm University has recently been on an expedition to the East Siberian Sea. The consensus used to be that the permafrost kept the methane locked at the bottom of the sea, but Gustafsson found this not to be the case.
Så det togs tusentals prover på många olika platser över det här stora området då. Och vi fann, i kontrast till vad man tidigare hade trott, att metan släpps fritt. Så det släpps fritt över ungefär hälften av den här stora ytan. Mängderna av metan som flödar ut i atmosfären är i storleksordningen 8 miljoner ton per år.
No one knows at which point we'll cross the tipping point and cause devastating amounts of methane to be released. It all depends on whether or not we're able to reduce our emissions of greenhouse gases. Prior to the industrialization of 150 years ago, the level of carbon dioxide in the atmosphere was 270 parts per million. Today it's 390. That's an increase of almost 50%.
Carbon dioxide emissions have been going up, up, up. If we continue on this fast track that we're on, we're probably heading up toward 800 to 1,000 ppm at the end of the century, which I would not hesitate to consider very likely to be a catastrophic scenario.
Stephen Schneider is one of the main authors for the United Nations Climate Panel. He's been looking at how the planet would react if a disaster scenario were to occur.
Well, with 1,000 ppm, we would probably warm up somewhere more than 4 degrees Celsius, maybe as high as 6 or 8. There would be major deglaciation of Greenland, 5 to 10 meters of sea level rise, intensified hurricanes, super fires, up to 40% of known species could be driven to extinction, really bad floods in Europe, goodbye Venice, and everybody will say, what have we done?
But could climate change render the planet uninhabitable and cause humanity to be wiped out?
Well, I'm not the biggest pessimist in this. I have colleagues who actually think that this worst-case scenario would drive humans to extinction. It would cause the outgassing of all the methane in the tundra and under the oceans, and that instead of warming up the equivalent of 1,000 ppm, we'd go twice that.
In the future, we may face a crisis and be forced to employ extreme measures.
Yes, so this is the idea of deliberately changing the Earth's climate. For example, by injecting soot into the atmosphere or by building mirrors in space that would block out some of the sunlight.
What is called geoengineering involves employing technical solutions to stop the planet from warming. It's like a plan B in case we're unable to reduce our emissions of carbon dioxide. But many believe that geoengineering could actually make things worse.
Geoengineering projects could cause their own risks. We know that when human beings begin to muck around with complex systems that we don't understand very well, it often turns out our interventions have side effects.
What are you going to do if there are side effects that you can never prove how much of it you contributed to? You have a risk where the cure is worse than the disease, so it's a very, very dangerous experiment.
It's not likely that humans could cause a climate disaster that would render the planet uninhabitable, no matter how hard we try. But in the worst-case scenario, we may be forced to do what animals and plants did 55 million years ago, and move to an ice-free Antarctica.
I would say that this is probably a larger risk than any of the ones we have previously considered here. The impact hazards, the supervolcanoes, or even perhaps the physics experiments.
That's why the threat of climate collapse ranks as number 4 on our doomsday list. No threat has been more tangible in recent times than this next one. October 1961. A Tupolev bomber is heading towards the Arctic Ocean. Major Andrei Donotsev is in charge of a weapons test, the magnitude of which the world has never seen, before or since. The plane's cargo is the most powerful bomb ever built, the so-called Tsar bomb. It has a yield of 50 megatons and is more than 3,000 times as powerful as the Hiroshima bomb. The mushroom cloud reaches an altitude of more than 60 kilometers, and the shock wave travels around the world 3 times before subsiding. The Tsar bomb was dropped during the height of the Cold War, 6 months after the Bay of Pigs invasion and 1 year before the Cuban Missile Crisis. Conflicts which could have led to the start of World War III. At one point, there were more than 70,000 nuclear weapons in the world. Today's nuclear arsenals are much smaller, but there are still thousands of American and Russian missiles that can be launched by simply pushing a button.
This dot represents the total explosive power of all the bombs used during World War II. 2 to 3 megatons explosive power, during which 50 million people died. The rest is the equivalent explosive power of the current nuclear arsenal.
One would think that the explosive force and the deadly levels of radiation would pose the greatest threats in the event of a nuclear war. But the most serious consequences for humanity would be caused by something else.
A nuclear bomb is like bringing a piece of the sun to the Earth for a fraction of a second. It's so bright that it's like a match. It will light on fire anything around within 10 kilometers or so. And it's the smoke from these fires that would last in the upper atmosphere for a number of years that would absorb sunlight and make it cold and dark at the Earth's surface that would cause the climate to change.
The sound of bombs exploding fades away and is replaced by silence as a devastating cloud rises up into the sky. Alan Robock's work shows that today's nuclear arsenal would indeed be sufficient to cause a radioactive winter.
This is the smoke and how it would be distributed around the world. The winds would blow it around the world, and it would, within 2 weeks, cover the entire planet. So it doesn't really matter where the smoke would go in. It would then be distributed by the winds and cover almost the entire inhabited part of the planet within a couple weeks.
According to this simulation, temperatures wouldn't even rise above freezing during summertime.
So this is the first summer after the smoke, this is the second summer after the smoke, and the third summer that the temperatures would be below freezing the whole time. So we really truly got nuclear winter. Agriculture would come to a halt, it would get cold and dark and dry, and most of the world would perish from famine.
The Cold War came to an end in the early 1990s, and the political situation is a lot less tense now. But one cannot dismiss the threat from possible future conflicts.
We shouldn't delude ourselves to thinking that because the Cold War passed without any nuclear incidents, therefore we are safe from the peril of nuclear war.
One thing is certain. Technological advances will result in newer and more powerful weapons. Future weapons may employ science that we cannot even see. Nanotechnology is about manipulating matter on an atomic and molecular scale. Working at the nano level enables us to make things stronger, more durable and more flexible. And it can also make it easier to fight diseases and environmental problems.
Basically, it's a very, very powerful technology once it's developed, which could be used to do a lot of good or a lot of evil.
Nanotechnology has a darker side. There's already been talk about creating nano-weapons.
There are many, many foreseeable weapon systems. One of many examples of the kind of weapon that could be built is autonomous or semi-autonomous flyers the size of mosquitoes, but each one capable of killing an unprotected human.
You could imagine maybe some canister that releases little robots that can fly and seek out humans and inject them with poison.
They land on the human, they inject you, you're dead.
The prototype for this scenario already exists. Autonomous flying machines are becoming ever smaller and more intelligent. And it's possible to envision an even more frightening scenario.
You could imagine microscopic bacteria-like nanotechnological machines that would be capable of harvesting resources from the natural environment and that could proliferate uncontrollably.
An armada of bacteria-sized machines could devastate enemy territory by consuming everything in their way. This is still far beyond the bounds of current science, but cannot be completely ruled out.
This, I think, is one of the major existential risks. It's zero right now, in the sense that we don't currently have the kind of nanotech weapons that could pose a threat to humanity. This is a future existential risk.
Are we going to build a weapon system that collectively could destroy the world, as our nuclear arsenal could? The answer to that is maybe, and the danger is still being analyzed. But I think it'll be a long time before we get to the point where a random madman or terrorist would be able to build a doomsday weapon out of molecular manufactured components.
World War I was called the Chemists' War. Tear gas, mustard gas and chlorine gas were produced for use on the battlefields of Europe. World War II gave us the atomic bomb. Which weapons World War III will be fought with, no one knows.
Einstein once said, I don't know with which weapons the Third World War will be fought, but the Fourth World War will be fought with sticks and stones. This is a category of different specific risks. Risks with nuclear weapons, risks with nanotech weapons, risks with weapons that haven't yet been invented. And so the overall likelihood that an existential disaster will occur as a result of a war seems fairly high.
The threat from a doomsday war ranks as number 3 on our list. In spot number 2, we find a threat that still belongs in the category of science fiction. It was thought to be impossible until it actually happened in 1997. A computer defeats the reigning world chess champion.
Ja, det absolut mest uppmärksammade och omskrivna partiet i datorschackhistorien så är det det andra partiet mellan Kasparov och Deep Blue 4 maj 1997 i New York. Inget annat parti har varit i närheten.
The supercomputer Deep Blue makes a move that catches Garry Kasparov completely off guard. Kasparov sets a trap, certain that the computer will fall for it. But the computer doesn't behave like those he's played against before. After 2 minutes of calculations, Deep Blue decides on a move that sets the stage for the world champion's downfall. Move 37 is completely unexpected, And later, Kasparov could only state that the machine seemed to have displayed human intelligence. It's not an exaggeration to state that we've entered the age of the machine. It would be impossible for us to go back to a world without computers and automation. Machines are essential for managing air traffic control, maintaining nuclear power plants, handling global communications, and controlling the world economy. Without them, our civilization would crumble. Those who fear that we're already at the mercy of machines will find even more things to fear in the future. There will be more machines, and they'll become even more advanced.
PR2 can open a door, can plug itself in, can grab a drink out of a fridge and fold towel. We have it doing a whole variety of different things.
Willow Garage in Silicon Valley develops tomorrow's household appliances. Here they are certain that robots will become just as common as dishwashers or computers are today.
This is the room where we do all the assembly. We build all the robots. We think they can improve people's productivity. I think they can improve people's quality of life. I think you'll see them in your house. You'll see them at work. A dishwasher is an excellent dishwashing robot. It's just not general purpose. If you could have that be a general purpose robot that could wash the dishes and could put them in the cupboard and could take them down off the shelf, all of a sudden that has a lot more value to somebody.
But could machines become sufficiently advanced and be given enough control so that they might become a threat to us? Could they turn on us, like we've seen in science fiction? Today's robots are still childlike. They've barely learned how to walk. But we can guess what the future will bring. It's not hard to imagine that robots could handle weapons, and not just drinks and footballs. The military has long had unmanned aerial vehicles. Now ground robots are appearing on the battlefield. Military robots are becoming so common that conferences are organized to discuss the ethical problems resulting from using robots in times of war.
People don't realize how many there are. There were very few in 2001, but now there's something like 7,000 robots being deployed in Afghanistan and Iraq. But the ones, and these are used for surveillance, they're used for bomb disposal, and we don't really object to those. What we really object to is weaponized, what we call weaponized platforms. That's robots carrying weapons.
These can be remote controlled, but they can also operate completely on their own. When the robot spots a target, it sets up a firing solution within a fraction of a second. Then it waits, so far anyway, for a human order to fire.
Part of the reason why these systems are autonomous is that there is a change in the tempo of warfare. There's no longer time to consult with humans sometime about engaging a target. That's a very serious concern. The question is, what level of authority are we going to give to these systems in terms of deciding whether to engage a target or not?
But for fiction to become fact, and for the machines to turn on us, it will take more than brute force. They will have to become intelligent. The scientific community is split on the issue of the possibility of creating artificial intelligence, or AI. Ben Goertzel is among those who argue that machines will not only reach our level, but that they will surpass us.
I would say it's 99% likely or more that within the next century, AIs will become massively more intelligent and more powerful than people, so that we're no longer the top dogs on the planet.
A brand new research strategy has raised expectations among advocates of AI. Scientists are now attempting to create a digital version of the human brain. Piece by piece, the brain is being converted into ones and zeros. synapse by synapse, brain cell by brain cell. If the effort is successful, the digital mind could be able to outperform its biological counterparts.
I think digital minds can be better than human brains in a number of dimensions. They can be more intelligent, they can be more ethical than human beings, and they can also be more adept at modifying and improving themselves.
A super-intelligent machine could handle all the planet's processes more efficiently than today's computer systems. But collaborating with machines could turn out to be a dangerous gamble.
This I would put either at or very near the top of the list of.
We can't rule out completely a scenario where we create AIs with goals that seem good to us, but later turn out to have been the wrong goal.
This might seem weird. It seems perhaps like pure science fiction, but a superintelligence would be able to very, very quickly develop all kinds of very powerful technologies that it could use to implement its will, whatever it be.
There's a chance that a digital mind could turn on us, and we can't be sure that we'll be able to put a stop to it in time.
So you might think, well, if it starts doing harmful things, you can just pull the plug on the superintelligence. Now, this is an action that the superintelligence could anticipate that we might take. So it will view the scenario in which the plug is pulled as a complete failure to realize its goals, and therefore take actions to prevent this from occurring. Maybe by hacking its way out to the internet so it can make backup copies of itself all over the place. Maybe by taking control of some robotic manipulators, and it could then use that to take power.
If we object, the artificial intelligence could employ the robots of the future to keep our hands away from the off switch. And if we take up arms, well, then it might decide it would be simpler to rid itself of these biological troublemakers.
Basically, by the time you have a superintelligence that is hostile to us or indifferent to our welfare, the only safe assumption is that by that time you've already lost. And therefore, what you got to do is make sure that the first time you build a superintelligence, it's a friendly superintelligence. With something like this, as indeed with all existential catastrophes, you only get one shot at getting it right.
The threat from super-intelligent machines is at number 2 on our list of existential threats. We've reached the number 1 spot on our list of doomsday scenarios. It was a Friday like any other in March 1979. But before the day's end, the staff at Military Compound 19 in the Soviet city of Sverdlovsk would cause a horrible accident. A technician removed a filter from a ventilation pipe. He noted this, but the people working the next shift failed to notice. While the filter was removed, spores of anthrax leaked out through the ventilation pipe.
The official number is about 80 people died, but unofficially we suspect that about 300 people died in this accident.
The employees at the ceramic plant across the street were the worst hit. Most of the people who worked there that day would die within a week, as a result of what became known as the biological Chernobyl. The superpowers of the Cold War have officially dismantled their biological weapon programs, but the ability to produce deadly microorganisms has not disappeared.
The Soviet Union produced hundreds of tons, you won't believe me, the hundreds of tons of biological weapons, enough to kill the whole population of Earth. Based on this historical example, we can project that the country with relatively moderate resources could produce a large amount of biological weapons.
By manipulating the genetic code, it's now possible to create new life forms. The research field is called synthetic biology, and many hope that this will help humanity deal with a wide range of problems.
People are actually interested in using synthetic biology to go and seek out tumors in the body, to clean up sites that have radiation. And so it's kind of your imagination is the limit for the field of synthetic biology.
But it's the hope that we'll be able to develop a new fuel for our cars and aeroplanes once we run out of oil that is currently driving major investments in this field. This grass will be genetically modified so that it will grow faster and taller. Then a superbacteria will be created that can convert the grass into biofuel.
So the goal is really to be able to cut and paste genes from any organism to make a renewable fuel.
The powerful potential of this technology has also led to a good deal of concern.
There are a lot of risks. You can't be 100% sure that we aren't going to release accidentally a microbe that we've genetically modified into the environment. And so there are also efforts to engineer in automatic death circuits so that these microbes essentially kill themselves if they're released into the environment.
But what most fear isn't that disaster will strike by accident. The potential for deliberate destruction is even greater. These two men caused a heated discussion about research ethics when they used synthetic biology to produce a dangerous virus. Eckhard Wimmer and Geronimo Cello downloaded the genetic makeup of the polio virus from the internet and acquired the DNA sequences by mail order. Using standard university lab equipment, they were able to bring the polio virus back to life.
It became suddenly very clear that if you can do this with a small virus like poliovirus, you may be able to do it one day with smallpox virus.
Their intent was not to spread the polio virus. They just wanted to demonstrate that it could easily be created.
People were shocked. It was of great concern to the public that it would be misused.
With the growing technological powers, particularly DNA synthesis machines and other techniques, we are right now going down a path where these kinds of capabilities will become available to anybody who wants to buy them for, a few $1,000 secondhand on eBay. So 10 years, 15 years, 20 years from now, unless something is done to stop this, anybody could be able to print out their own version of the smallpox virus or Ebola virus.
In the 21st century, synthetic biology appears to be the greatest threat to mankind, and it is at the top of our doomsday list. Our top 10 list of doomsday scenarios is thereby complete. But there is actually one remaining threat that could be more serious than all of the others combined. There is an 11th card in the deck. Pripyat gives us the chance to observe one possible future. It shows us what a world without humans might look like. Whether mankind's journey will be long or short could depend on our ability to survive this century.
If we make it through, from that point on, the risk of human extinction and existential catastrophe might decline, and the lifespan for the human species at that point might become extremely long, and the future of humanity could be far, far greater than our past.